Hi there, this is my favorite lesson. Let's talk about how to bring your work alive with light. You may know that the tonal value of a surface depends on the angle between the direction of the surface and the direction of the light. We're going to take a close look at how exactly this happens. Chances are that you're missing a subtle but important insight that makes your drawings look much flatter than they could be. This drawing by Alan Lawson is a great example of good shading. The form is very clear. The image has life, and there's nothing that's too bright or too dark. There's nothing that feels muddy or dirty. This is not as difficult to do as you might think. You can do it if you understand one key principle: the relationship between inclination and brightness. Here's a levitating plane and a light source directly above it. I'm going to rotate this plane away from the light source. You can see the degrees of rotation on the controller to the left. As the plane turns away from the light source, it gets darker and darker until it drops into shadow. And then as we rotate it back, it gets brighter and brighter as it receives more and more light energy. Let's take a closer look at this plane. The light is coming straight from above. Can you see what happens as we turn the plane? We can count the light rays that are hitting this plane. 1, 2, 3, 4, 5, 6, 7. There are 7 units of light impacting the surface of our plane. If you rotate the plane, now it's only receiving 5 units of light. So it's getting darker. If we turn it more, now we have 3 units of light hitting the plane. And if we turn it to 90 degrees, it's not receiving any light anymore. It's now just getting light on this little plane up here. This is the moment of the Terminator, when light turns into shadow. So there's clearly a relationship between the inclination of our plane and the brightness, the tonal value of it. We measure inclination in degrees and brightness in percent. So we are now at 0 degrees inclination and we have 100% of brightness. As we rotate to the other extreme, here we have 90 degrees of inclination and 0% of brightness. My question to you right now is, if we turn this plane back by 10 degrees, so we're at 80 degrees of inclination, how much brightness do we get? It goes from 0 to what? I'll give you a moment to think. Make an estimation and write it down on a piece of paper. You can stop this video if you need more time to think. I'm going to reveal the solution in 3, 2, 1. It's 45%. Now this might surprise you. How can we go from 0% to 45% in just 10 degrees of rotation? Most people expect something like 10%. Now, what do you think about the other extreme? At 0 degrees of inclination, we have 100% of brightness. If we turn by 10 degrees, how much brightness are we left with? Make another guess and write it down. And I will reveal in 3, 2, 1. Ready? 99%. What? This should be blowing your mind. If it's not, maybe you're already familiar with this concept, or maybe I just went too fast. So if you feel lost right now, you missed one of the biggest points of this entire course. I'm serious. Go back and watch the last 2 minutes again. This is very important. Otherwise, let me explain what happened here. We start at 0 degrees of inclination with 100% of brightness. Then we rotate the plane in 10 degree steps, and the brightness drops from 100 to 99, 97, 94, 89, 82, 73, 62, 45, and 0. So you can see there's an increase in speed of darkening. What most people expect intuitively is a linear scale that goes from 100 to 90, 80, 70, 60, and so on. But that's not what's happening with light on form. If you understand this, your shading is going to improve from this day forward. Let's take a closer look. What matters most for us is that as form turns away from the light, the tonal value darkens very, very slowly at first. That's in the light halftones. And then it speeds up and gets really dark really quickly, just before the terminator. This is the scale on the left. Let's call it light on form scale. In contrast, here's what happens with a linear scale on the graph. The tonal values are changing gradually in even steps. Okay, let's play this again, but this time looking at this planar sphere. The light halftones are all very close together in brightness. What creates the sense of form in your drawings is that the value changes and keeps changing continuously. It darkens and darkens very slowly in the light halftones, then it picks up speed and darkens more quickly until there's a dramatic value change in the dark halftones, just before the form turns into shadow. This is it. This is the key to successful shading, to creating the illusion of form. If we take these two gradients and put them on top of the planar sphere, you can see that the light on form gradient works much better. The linear gradient goes way too dark, way too soon. This results in dirty lights and flat shading. These are both things you probably don't want. And in case you're wondering, the form shadow of the sphere is not black, only because of the floor. If we go back to this drawing, you can see that almost the entire form is modeled with light halftones. The dark halftones are in very specific areas, just before the terminator, for example in the thigh or in the chest. This new understanding might give you a deeper appreciation for some artists. It is possible to communicate a tremendous amount of form change with a limited range of values. This requires sensitivity and control. You can develop both of these through practice.